Okay, it's on. Please take the floor.
Okay, today we'll speak a little bit about Zenoh and how security could be applied in Zenoh. So I prepared some slide at first to explain how we have security in Zenoh. Let me share my screen here. Okay, so how can we apply security for ROS2 when using RMW Zenoh? So just first a reminder on how RMW Zenoh is configured with regard to connectivity and so on. So this is the settings by default with regard to deployment and communication. So the ROS nodes inside a robot are deployed in different processes, depending if you configure intra-process or yes or not. And so in addition of this, you have a Zenoh router, which is used for discovery. So by default, the router is listening on TCP over the loopback, so without any security, plain TCP. And each node connects to the router on this loopback interface. And there will be a gossip discovery protocol, meaning that all the locator will be exchanged between all the nodes, and the nodes will establish peer-to-peer connections on the loopback interface using plain TCP. And then for external communication, the router can be configured with various different transports over the Wi-Fi or over whatever interconnectivity there is outside the robot. So it could be TCP, TLS, QUIC, or a lot of other transports that Zenoh can provide. So the benefits of this is less connections, of course, less overhead. We perform also automatic batching between the routers, so meaning we can improve the throughput with batching all small messages in a bigger messages. And for security point of view, there is a smaller surface of attack because there is only one open port on the inside for the Zenoh router. The nodes cannot be reached directly from the outside. And there is a single point to configure access control, which is inside the Zenoh router. So that is the default deployment, let's say, when you use RMW Zenoh out of the box. But still, the user can change the configuration. And for instance, he can just leverage UDP multicast for discovery, so bypassing the router, or having configured explicitly an external node to directly connect to a node inside the robot. Of course, you need also to configure this node inside the robot to expose a port number to be reachable. So there are various deployment possibilities that are possible with Zenoh. So now let's see what Zenoh can offer with regard to security. So for security model, for encryption, Zenoh relies on TLS over TCP or TLS over QUIC. For authentication, Zenoh supports mutual authentication over TCP and over QUIC, so leveraging a common root CA, and all the clients and server signed by the same root CA can authenticate with each other and communicate with each other. There is no support yet for CRL. That's something we need to implement that will come later. And then optionally, Zenoh also supports username and password. So similarly, for instance, to what is done in MQTT, in Mosquito, for instance, when you can have, for instance, you can still use TLS, right, but use the same certificate for all your clients. But then you can, in addition of this, use username and password to authenticate within a TLS connection, which is not authentified per se. You can also, by the way, use user and password without TLS. That's totally orthogonal. And then for access control in Zenoh is configured per Zenoh session and per Zenoh router. So it means at Zenoh, the mapping between Zenoh session and ROS concept is in the context, right? A same ROS context is having one Zenoh session. So it means if several nodes are in the same context, they will share the same Zenoh session. Then the access control rules, the subject will be defined by the certificate's common name or the username configured with the username and password, or also via network interface. Meaning, for instance, you can define access control rule in Zenoh to say over Wi-Fi interface, I want to deny all those publications, those services, those actions, and so on. In Zenoh, the security is made up to up. It's not end to end, meaning that if you have a router in the middle, the router will be able to decrypt and re-encrypt all your data. And meaning that, for instance, here, if we have a peer A connected to a router and communicating with a peer B, the peer A will authenticate and encrypt with regard to the router certificates and will apply the access control rule for this router. On the other end, the router will authenticate the peer A, will decrypt from everything coming from the peer A, and will apply the access control rule, which are for the peer A. And then on the other link to peer B, it will be the same thing, but with access control rule based on between the peer B and the router. So there is no way to, at this stage, at least, to have end-to-end authentication or end-to-end encryption. You need to trust the router. How is defined the access control rule in Zenoh? You have a set of 3 lists so it's in the configuration file for the session, which is a JSON file. There is a specific structure part for the access control, and here you can define 3 lists. First list is the list of roles. That's where you define all the permission with regard to message flow. So you define the ingress and or the egress for your messages, the message types, which in Zenoh are put operation, query operation, replies, and also the declare message, declaration of a subscription or declaration of a queryable in Zenoh, which is in ROS will be a service server. And of course, the key expression of concerning the messages. Then the second set of list is the subjects. So how do you identify a set of interlocutors? You can identify those interlocutors via certificate names or via usernames, or even, for instance, via a network interface if you're sure that your interlocutors are always on the same network interface. And then last list is a set of policies, which is a mapping between the rules definitions and the subject definitions. So let's have a quick example in here, for instance, for a talker listener example. So maybe it's small, but unfortunately it's quite a big file. So here, well, there is an error here. Access control, of course, need to be enabled, so it shall be enabled true and not false. Sorry about this. The default permission, you can set a default permission. So here, by default, for security, we set permission by default will be denied. And then we have a set of rules. So here, I define a first rule for the talker egress destination. So I will allow in egress only the publication to the key expression, which is the chatter message. So here, for configuration, we need the configurator need to be aware of the mapping between the ROS topic names and the key expression used in Zenoh. So the current pattern in RMW Zenoh is described here. So it's domain ID / the topic name. So here it shall be the full topic name, so which can include some slashes, which can include also the namespace and so on. / the topic type. Topic type being the type definition in C++ format, so with a column as separator, so the same topic type that you can see when you do a topic info, ROS to topic info. And then / the type hash. So the type hash as computed at compilation time, at code generation time, with recent version of ROS 2 for since Iron, I think. So, but for simplicity, the user can use star, which will map any chunk. So here, when I I put here star/chatter/star/star. It means any domain, the chatter topic name with any topic type and any type hash. To enforce the security, I could probably set the exact topic type and the exact topic type hash that we are used by ROS2. So that's for the egress rule for the talker. We need to allow publication to get out, but we need also to allow the declaration of subscriber to get in. So we have a second rule, which is for talker ingress message. We have the declare subscriber message allowed to come in. And then we have two rules for the listener. So the listener shall allow in egress the declare subscriber and in ingress the publication messages. That's the symmetric of the talker. Second part, we have the subject. So the subject here is the relationship between an identifier and the certificate common names. So here we imagine we have a talker and listener as common names for simplification. So we just reuse the same. And then we apply the policies. So for the talker, we apply the rule talker egress and talker ingress. And for the listener, we apply the rules listener egress and listener ingress. So that's it. Is there any question?
So me and Mikhail did a little dive into the sort of the policy enforcement points. So at the moment they're purely evaluated on the router, correct?
No, the access control rule can be also configured per session. So it means, for instance, here, in the example I just gave, those access control rule will be configured for both listener and talker nodes. They don't need to be enforced by the router, and they shall not be anyway, because by default configuration, all the communication will be peer-to-peer between the talker and the listener node. The router will just serve as a discovery service.
So in terms of the enforcement, each node, let's say if they're running as different processes, so they're not like exactly the same context, but they're like maybe they're in the same network interface, and so you're defining your policies in terms of subject names rather than network interfaces. Each node is going to look up the other node's subject name based on the TLS handshake and the common name of the certificate, and
Correct.
evaluate the policy locally.
Yes.
So there's this assumption that we distribute the policy across all hosts. I guess it's like a config file, and that's how it's delivered.
Yes, exactly. Yeah, that's in the Zenoh session config file, which is a JSON file, and there is this section which is related to access control. So, for instance, if you look into the Zenoh code base, there is an example here of a default config file. So that's the configuration file for a Zenoh session or for a Zenoh router, because that's the same config file. And in here, you can find this access control setting. So that's where you will configure the access control rule for each of your node and for the router, in case your router will be the intermediate for external communication.
Okay. And DDS, we have this premise of not only a permission file, but also like a governance file. These files are signed. And so during the handshake, they exchange each other's signed XML files. And then there was a whole chain of trust with the root certificate to evaluate whether the opposite agent's proposed policy was authorized by the root certificate issuer. In this case, the configuration file that's on say the same disk as the host machine, the node, that is assumed to be trusted implicitly, right?
Yeah, that's correct.
Okay.
There is no mechanism of signature of the configuration file or the access rule for Zenoh. That's something which is different than DDS.
Thank you. I think we had a message in the chat.
Yep, I think. So by default, there is no access control rule at all. So then it's up to the user or to the SROS generation of configuration file to define what shall be the default configuration, right? So in Zenoh configuration, by default, everything is allowed. And then when you define access control rule, you can define what shall be the default behavior. It can be either deny by default or allow by default. Is encryption by default based on which certificate? So no, by default, Zenoh will use plain TCP without any encryption. And then if you want to configure TLS, you need to configure the Zenoh session to use TLS and to provide the certificate. So the certificate has to be provided for each Zenoh session. So for each context in ROS.
And so just to confirm, like within that session, everything will be using TLS and everything will be encrypted, every single topic belonging to that session.
Yes, well, it will be encrypted with regard to connectivity with outside. So yes, all the discovery protocol, let's say, which is based on liveliness token in Zenoh, but all the discovery declaration and messages, request, reply will be transferred via the same TLS connection.
Like just to confirm, I understood is that, like, example, I have a camera node that is streaming data, and some control topics, and so if I decide to encrypt the control topic, all my camera data will be encrypted as well because within the same session.
It depends where are your subscriber. You can configure, for instance, you can configure your camera node to have two different endpoints, one in plain TCP and one in TLS, and then configure the control to be on TLS, to be connected to TLS, and the camera stream to be using the TCP connection. And then you can, in this way, you can have the two behaviors.
Okay, thank you. Clarifying.
Julien, a clarification on this. Okay, this is partially true. That's not how it's supposed to work. What we can do in Zenoh is to distinguish per priority or per reliability class, whether best effort or reliable. So when you need to think about a Zenoh as a network graph with all the edges between the nodes, okay? So basically, every edge is your connectivity that you can set up in a TCP or TLS, okay? So having something, say, hey, I've got my control data and my TLS and my camera data to go over different links, actually it's more accurate way to say, if you've got different priorities, we can schedule it on different links. It may happen that those links are TCP or TLS. Okay, so we cannot schedule, there is no possibility to schedule a given topic on a given link.
Okay, I agree, Lucas. That's a way to do it. But still, if you have three different processors, the camera, the controller, and the display of the camera, you can configure the display of the camera to connect with TCP to the camera, and the controller to connect with TLS to the camera.
You have different sessions, yes. But for example, let's assume that.
Oh yes, okay, yes. In this case, I have two different sessions. I have the session for the controller and the session for the subscriber of the stream. That's correct.
But then if you say that, for example, I want to connect to the robot from outside the robot, so I connect to the router, there I've got one connection.
Indeed, yeah, that's correct. So, yeah, it might be more complex than when I said, depending the connectivity deployment that you said. If there is only one connection for both control message and streaming, then as Lucas said, you need to establish 2 different connections and then to base on priority for Zenoh to decide which link to use, either TLS, either TCP. Yeah. Last questions from Mirko. What is the overhead when enabling regexp for the rules? I think. What do you think of this?
So using interceptors already has a certain cost, and then depending on the rules you have, there is an additional cost depending on the complexity of the key expressions. So, for instance, if you're matching each message with a key expression that has a lot of wildcards, a lot of verbatim chunks, there are things that are more costly than wildcards in what are they called? Key expressions, yeah. But yeah, depending on your rules and on how many rules apply to each message, you may see a big cost. So that's also part of the complexity of setting up ACL properly.
Yeah, but what do we mean here with big cost?
Yeah, I never measured it specifically, but personally, I have in my backlog a task of looking at the cost of it and trying to maybe optimize it, because there is a cost that I can tell.
Okay.
So if to summarize it very quickly, so there is a lookup cost on that. Okay, so the bigger your rule set, the higher will be the cost. The more complex your key expression, the higher the cost. Basically, that mainly translates in terms of throughput. But again, we are still talking about throughput higher than what we usually experience on a ROS 2 system. By default, on Zenoh, on localhost, we are talking about 1 million messages per second. So it can have an impact on the throughput, but still talking about 100,000 messages per second. Just a rough estimation.
Yeah. So indeed, if there is a way for the tool generating this rule to get information about the topic type on type hash, it will be better, yes, to give the exact topic type on type hash to have a complete key expression, and also the domain ID. Yeah, that will be more efficient, indeed.
And so I have a couple questions related to that. The first one is like, so the goal is to integrate security in the next version of ROS 2. And that version will have full wildcard support, right? Like I saw something in the webinar, like it was waiting for Zenoh 1.0 to get some support.
Yeah, exactly. Yes, absolutely. So it's currently the case. So well, we just need to merge the pull request to port RMW Zenoh to Zenoh 1.0.
Mm-hmm.
That's correct. This usage of wildcard here is supported only in Zenoh 1.0. So we need RMW Zenoh to use Zenoh 1.0, but that's work in progress, and that will come hopefully in the coming weeks. We're just finishing to fix some tests.
Perfect. So we'll take that as an assumption, a starting assumption that like this will be available.
Yeah.
And so another question, I think it's been answered a bit with I didn't know the hub to hub, like the hub by hub thing, because one question I had when I read the initial docs was if I have like my basically regular set of rules, which is like, okay, my robot, the type of commands and data that can enter and exit my robot are this, and this. But then I want a maintenance debug user that will be able to introspect a lot more data in my system. So I can have like in the robot configuration, like a set of extended rules for that specific common name or that specific user, and we'll be able to like have this like extended access.
Yeah, I think that's a way to go. Then, depending on what this user shall discover, you can, for instance, authorize only the discovery part, so the declaration and so on. So user will be able to, for instance, to reconstruct the full ROS graph, but not to subscribe to some topics. That could be an option. And by the way, do we because here I didn't saw access control with regard to liveliness token. We have some plans for this.
It's gonna be supported soon. Yes, it's planned for the next patches.
For the next patches, okay, okay. Yes, because in ROS, all the discovery is based on liveliness tokens, which are a different set of messages than publication, subscription, query, reply. For the current version, there is no access control rule with regard to liveliness token, meaning that everybody can get and publish liveliness tokens. In the coming patches, so by before end of the year probably, we will have extra additional access control rules with regard to liveliness tokens, and hence with regard to ROS graph discovery.
Okay, and this is I didn't look at all into discovery. This is not like the key expression don't include ROS specific stuff for that. Like, how do you declare? I mean, I guess we'll see when it's implemented, but like just to know if on the ROS side there is something to be known to generate those.
Yes, there is something to be known. The key expression for liveliness token is more complex than this one, because
but I mean, I haven't started implementing it yet, but I plan on having it be the same as what you use in the API. So you don't have to complete the entire key expression with like all the bottom chunk and everything.
Okay.
You just give it the part you give it to the API, and the config should be able to complete that.
Okay. Yeah.
I mean, I think it's possible, but I don't know if.
Okay, but still in the liveliness token used by ROS, there are extra information, for instance, with regard to the QoS, which don't appear in the topic. But in the liveliness token for ROS graph, for instance, in order to know if some topics are matching or not, the QoS is encoded within the key expression for the liveliness token. So even if we don't have this prefix, which is specific to liveliness tokens, there will be still some additional chunk here for ROS2 liveliness tokens. Yeah.
Sounds good. And so I guess the implication of my previous question of like different types of users or subjects having different rights, that also means that if there is not this exchange of rules and validation, if it's encoded in the router, if I want to like create a new like type of user that can access specific data, I need to go change the configuration of my running system, right? Like I need to go change the configuration file on my robot to allow my new debug user to access one extra topic.
Yes.
Okay.
Yes, and it's not possible to change this at runtime. So you need to restart the node to apply the new configuration.
Okay. And one more question I had. So I saw it's JSON 5 because there is comments, and that's awesome. But one question is, so it feels like it's like one big file with all the configuration. And so if we were to generate something, that means we need to inject in this file, or because like, or does new JSON allow like to basically include other files?
So default no. and we don't have this feature. There are some other applications, like for instance, you can see in Home Assistant, they have the possibility to include some file in a bigger file. It's not implemented yet in Zenoh, so it's something which is required. We can consider to add this feature. Yeah.
I mean,
because-
hard to define if it's required or not. It's just like seems that the chances of messing it up and making it hard to read if there are many rules.
I agree that it will be more convenient to have the possibility to split the configuration file in subfile and to have a specific file for the access control part, for instance. Yeah. Then of course, in this case, if we support this, it will be easier to generate the file for access control part rather than to patch it.
Well, in any case, I believe that at least as a rule of thumb, I believe that even if you split in a different file, in the main config file, you need to point to this new file. So you still need to patch it somehow, because you need to enable access control and to point to the file.
I think it's more of a point like of management. So like you have huge amounts of nodes, and you might have subfiles that have been certified and validated for the subset of your system. And when you compose, like with the navigation stack, with like your localization stack, suddenly you want the union of like those configurations. And so in the prior stuff with SROS2 and DDS, and we're using XML, we can just use X-include to kind of make references to other files that the XML parser would just pick up automatically. We could probably do something fairly similar with like, defining a custom domain-specific language in this JSON, saying like, this particular key is meant to reference another file, just parse that, and then include it in this subdictionary when loading the entire dictionary of the JSON. But I think we could probably do something along that lines of just having a DSL for those particular features.
Absolutely, yeah. But yeah, that's something we would need to add in Zenoh. Yeah. But with regard to your remark, Luca, I think by default we could have some rule with regard to relative path to the main config file, right? And let's say that if we specify ./access_rule.json, that's the same directories, I mean, for the main file, and hence there will be no need to change the main configuration file, the access.
To be discussed, because I mean, it's something that will need to work everywhere in every system, in every platform.
Yeah.
Not only for ROS. Okay, if we go down there.
Yeah, indeed.
One thing I thought was a little kind of unique is in the namespacing of from ROS to Zenoh topics, the type ID and the type ID hash are included in this namespace. Do you foresee any gotchas that might arise in terms of, particularly when people are like needing to use wildcards to alias over types and hashes? It could inadvertently lead to allowed topic spaces that that someone could use. Like I think misuse of permissions was one thing. Yeah, I guess the user could always do fully qualified permissions for everything, particularly with Zenoh having the centralized discovery. It's a lot easier to take these kind of measurements, but maybe there's some exposure there.
So if we take a concrete example, Rafin, what you have in mind is that like if someone doesn't want to like wildcard like type and hash or whatever, in this chatter example would use like a /**, and then it would end up matching also a topic that is chatter / something that you are not expecting to allow in the first place. Is that the type of thing you have in mind?
Yeah, is there any unique delimiter in the message type syntax string that I could anchor a permission to? So like this needs to terminate with a type. It can't just continue on with a arbitrary Zenoh topic namespace.
So here, when I use a single star, it's a single chunk between two slashes. So it means here for the pattern, for instance, there are only 4 chunks. This pattern with 3 stars on chatter will only match key expression with 4 chunks exactly, and with chatter as a second chunk. Of course, you could use star star in Zenoh. So star star in Zenoh means it matches several chunks. So in this case, as Michael mentioned, yes, there could be a matching with something which, for instance, a topic which will be chatter/ABC. It will match also chatter/ABC. So my advice would be rather to stick with the exact number of chunk which is expected, right? And then to enforce security, of course, to not use wildcard at all, but to stick with the generated topic type and type hash for each topic.
Very good. What use cases do you see password and username, and maybe particularly without TLS? Like, how is that working over clear text in those kind of scenarios?
Not necessarily clear text. You could connect to a TLS endpoint, so still have your communication encrypted, but not use mutual TLS mutual TLS. So the server won't authenticate you, and then you could use user password as your authentication method. So you authenticate with user password through a TLS encrypted communication.
Okay, so server-side authentication, just like any TLS session, can be configured, enabled, or disabled. Okay.
Yeah. So you could disable it and use a user password instead, which depends on what you used in ACL to configure. I mean, it amounts to the same. You either have N certificates or N usernames, so basically the same, I guess.
Thank you.
Yadu, you wanted to ask something?
Yeah, just wanted to comment on that type hash question that Ruffin had. So one reason we include the type hash in the key expression is to also ensure safety when we deserialize the data that we get. Because if we just subscribe to things with the same topic, you could have different messages being published over the same topic. And when the type support tries to deserialize into a ROS type, it could lead to some explosions there. So that's one of the reasons we included the type hash in the key expression. But now this also poses the question of some safety now. If we do use wildcards for the type hash, there is this chance of deserializing the wrong type that could happen. Well, not just the type hash, sorry, even the topic type. So if we try to deserialize the wrong topic type, that could lead to an explosion. With a different type hash, there is the risk of, we might have added or removed some fields to the same message. And then, yeah, similar situation could happen. So we're also working on this concept called evolving types on the ROS2 side, where, you could take a standard message like nav message odometry, and then maybe you add some fields to it. Obviously, we wouldn't backport this to older distros, but we might want to have a newer distro talk to an older distro. So the type hashes would be different, but we still want communication to happen. So I guess these are some challenges we should also consider when using wildcards.
So just to be clear.
Sorry, go ahead.
Yes, sorry. Just to be clear here, when we use wildcard here, it's only to apply the rule, right? It won't change anything with regard to matching between publisher and subscriber. It won't allow any way publisher with a certain type hash to match a subscriber with a different type hash for the same topic.
I see. Okay. That's the key point I missed out. Thanks, Julien.
Welcome.
So there's in this intent maybe in the future we'll have evolving types similar to optional or deprecated fields like in protobuf, and so that's something we might want to account for in our security generation tooling. Is that correct?
Well, based on what Julien just explained, it seemed like the rules here are just for matching, and they're not. At the end of the day, it'll still be the type support's job to ensure we support these new optional types and whatnot.
Yeah, my understanding of that is that like actually we can generate a wildcard for the hash. Zenoh will take care of matching like actual subscriber and publishers, and so we will be ensured that there is the right type and it can be used or whatever. So this is just for rule matching. So I think for now at least we don't need to worry too much about it.
Yeah, I agree. Yes, that's.
Yeah.
Well, just to explain again the way it's implemented via interceptors inside Zenoh. So this key expression is just to decide for an interceptor if it shall apply the rule or not, right? But the publication will still be on the full key expression that includes the type hash, the topic type, and so on. But just depending on this key expression, the session decide if it applies the rule or not.
And just one thing to confirm. So we talked about root CA. Do we agree that if things are using intermediate CAs, as long as they have the same root CA, the chain of trust will be okay and they can communicate?
Yep.
Cool.
So I have one quick question. Is there any equivalent of a certificate revocation list in case you would like to apply or revoke the access of any of the nodes in the access control list?
Not yet.
Not yet.
That's something we need to plan, to consider and to plan.
What TLS library are we using? So like if we're moving to Zenoh 1.0, the C++ wrapper that goes to we're using a ROS-based TLS library
Yeah.
just underneath the hood.
Rust, yeah.
We can forego OpenSSL. That's great.
Exactly.
Yeah, no OpenSSL, no nightmare about cross-compiling OpenSSL there.
By the way, with regard to CRL, certificate revocation list, I think as far as I remember in DDS, there is no central point to manage this revocation list, right? It's also distributed files to be loaded by each participant. Am I correct?
I'll be honest, I don't remember.
Did X509 have a method for pointing to a revocation endpoint?
Yes, I think there is, but I was just wondering if it's used for DDS or not.
I think that was very vendor specific. DDS vendors like how people interpreted
And what
load the certificates.
Okay, and what will be the best practice for robotic? Because my guess is that such endpoint for revocation list might not be always reachable, right? It's usually over the internet or deployed in single point.
Yeah, it's a different premise than if you're making a cloud-based web application.
So do you know what's the current practice for robotics? It's just a list which is deployed for each robots or each node?
Common practice in robotics today is no security.
Okay, that's easier. So, well, yes, so with regard to certificate revocation, if you have some requirements of some inputs to how to achieve this, we can take this in account for future plans.
Well, so now I have the main hardest question is that how is the integration into ROS2 planned so far? Like, are there people at Intrinsic that are like driving that effort, and how should we coordinate on this to make it happen?
I'd say right now our focus has been getting RMW Zenoh compatible with Zenoh 1.0. So if we could get community contributions for either generating these access control files or finding ways to inject access control configs into existing Zenoh configs, that could be really useful for us. But the immediate focus is really getting all the tests to pass so that we can run CI with RMW Zenoh. But this would definitely be something we need to get in before Kilted release in May. So the more support we can get, that would be amazing.
Yeah, because I don't remember the timeline exactly, but basically like features have to be in like March or something like that, so that they can like, I get fairly core stuff.
Exactly. So usually the RMW freeze is before all the other freezes, just so that we can run CI with a stable release of RMW. So we would need to aim to get this stuff in by end of March, I would say.
Is there somewhere a list of the minimal set of requirements, let's say, to be compliant with SROS? Like, for instance, is a CRL revocation list something which is required or not? Or is there the need of end-to-end encryption? Or what will be the minimum feature required to be SROS compliant?
Probably just a workflow, so that, I mean, this isn't specific to the Zenoh end, but just like where we can bring up a system, we can take our measurement about the topology, and then once we have the topology, we can make heuristics on generating the policies that are like the minimum spanning that reflect that. So one would be maybe some guidance on what we use to query the system. So I guess there must be some APIs that we can ask the router. What's your current state of your graph? But some of the capabilities that this policy has, like binding access control policies to interface, not necessarily just to subjects, is a bit novel. So I'm not exactly sure how best to maybe guide end users to make those decisions. Okay.
Yeah, I guess there are like two questions in this one. So one I cannot answer, which is like, what is considered by Open Robotics as necessary for being tier 1 with regard to security? I don't know what the state of things is. Before it was like implementing some DDS security plugins, and it was implementing all of them. Today, for a case like Zenoh, I don't really know what this minimal set of requirements would be. On the more technical side, so that's to complement what Ruffin was saying, is basically we need to have a way to tell RMW and so tell Zenoh how to find what. So where are your security artifacts? And then, in my opinion, we need a way to generate and ease that for users. And so that goes along the what Ruffin was saying about workflow, which is like, how, as a user, I can audit my system. I can have a set of tools to help me generate what I need to secure that system. And how do I deploy that? But it doesn't have to be fully automated. It doesn't have to be, it's just like a way of doing that. From the technical point of view, that's also all we would need to look into generating the right type of artifacts.
Okay, so that's let's say the equivalent to the current Python scripts that are in SROS repository, right? To generate all the XML files, the certificates, and the public and private keys.
Exactly. Yeah, it would be really just like being able to generate the keys as we do today, and basically implement in SROS2 a different like there are like endpoints or like plug-in points in SROS2 would be to like define exactly what we need to do for the Zenoh one, so that instead of generating and signing XML files, it generates the right type of stuff in JSON, so that then it can be used by Zenoh. And then see if there is anything missing in the RMW API, which is currently used to pass also like the path to the PEM files or things like that. So if there is anything to change there to pass Zenoh everything that's needed. But yeah, except from that, I don't see much.
Yeah, on this, I don't think there is anything needed because currently the configuration file is passed via the environment variable, right? There are two environment variables, one for the session, one for the router. That's the path to the main configuration file for a Zenoh session. And then we have two solutions, either everything in the same file, as it's currently the case, so there will be nothing to change. Either anyway, if we manage to make Zenoh to change to support multiple files for configuration, my guess is that the main file will point to the correct path for the subfiles, let's say. So either in a relative path, either with the absolute path.
And then that's also something, and like I don't know what the core team would say, but like I mean, if the tooling generates the right chunk of configuration that they may have to copy in their main big configuration file, like it would not be like as nice to maintain or whatever, but it's usable. So like it's very hard for me to say what would be the minimum requirement. I think the minimum requirement is to have a way to enable security and to make sure to do it in a decent way, in a decent workflow. And so I guess what would come out is that like it would be a configuration file with like by default denial and just have allow rules for whatever has been audited and validated on the system, and being able to point to the right security artifacts.
So what I saw from the Python script in SROS, that anyway everything is generated in a well-defined hierarchy of directories per enclave, per nodes, and so on. And then for each node, there is a subdirectory containing the public key, private key, and DDS security configuration file. So my guess is that for Zenoh, we can do exactly the same, right? To generate for each node a directory with the certificates, a private key, plus the configuration file for the full session, which will be a copy of the default configuration file that exists already in RMW Zenoh repository. And we just generate this file with a change for the TLS configuration, endpoints, certificates, and so on, and for access control rule, depending of what is made. The only gotcha I have right now is that, as far as I saw, there is a command, right, to customize the access control rule in Python, in the Python script, which is based on XLS, so XML transformation, and Zenoh doesn't support XMLs yet as configuration. So we have two options here. Either we generate XML configuration and we make a change in Zenoh to support XML configuration. That could be possible because we use a library in Zenoh for configuration which already supports JSON, JSON file 5, YAML, and 2ML. I think it might also support XML. That's something we need to check. That could be one option. Either we change the XLS configuration to generate JSON instead of XML.
I think the later option is pretty dead simple. Yeah, like right now, I just I used XLS because of its import extensions. It made it easy to write composable policies. And then the resulting string format of the output file is just determined by the XLS template itself.
Okay.
So that's not too bad to implement, unless we wanted to follow some kind of a redesign or make everything holistic in config. But maybe that amount of churn isn't worth re-implementing. But certainly the later option is pretty dead simple to implement, because
Okay.
we operate sort of on the same abstractions of permissions, subjects, policies. There's some unique, because you what were the three main root case? There was the rules, subjects, and policies. And I think the formation of the policies is a bit unique because it had different dimensions, like network interfaces. But that shouldn't be too hard to refactor the Python logic to incorporate that.
Okay, I didn't know XSL can generate JSON, so that's fine. Yeah, that makes sense actually. Yes, yeah. As soon as you have a template in the output format you want, yeah. Okay, good to know.
Well, so I guess before we conclude, maybe maybe we can list a couple, like, I don't know, target, date, and action items. Just so I guess we'll start digging into this once 1.0.0 is merged, to have something to like try it on the last version. And then I guess on the Zenoh side, we know that CRL will happen at some point, but we don't need to worry about it too much right now. And on the SROS2 side, Rafin, we should like look into in the current structure and templating. Is there any gotchas in trying to provide Zenoh compatible templates? And see if we're missing information to be able to implement it. And in that case, we can like interact with Julien's team to clarify things. All right.
Maybe something that could be useful is will be a set of examples of use cases. Maybe just I can take the basic example like talker listener, Fibonacci, and so on, and to at least generate already by hand the configuration that shall be applied, and then we can review this together and see how it could be generated from the Python script.
Got another question, right? Regarding in RNW Zenoh, you've got a set of tests that we need to pass for the RNW implementation. Is there any test suite for secure ROS?
Yes, there was. So I think I implemented two packages a while back. There is one called test communication that is like testing communication without security, and I think then something like test security or something like that. It must be like in the ROS2 system tests or something like that. And so I think it's I can have a look. I've done something else in the chat in the meantime.
There's also your SROS CMake, or is that what the test security was using?
Yeah, that was just testing the generation of stuff, but it's not testing communication, I believe. I'll have a look, but I think
Is this the one you mentioned in ROS2 system test security?
yeah, in system. Yeah, I think that's the one. Like, I think I don't know like what is the status of his but like there was like basically a way to generate the artifact and then to basically test communication between nodes using these artifacts.
Has never failed.
Okay, so we will need to check at least if this. So my colleague here is saying, Stephen is saying that this test is passing for the time being, but I guess its security is not enabled, so there shall be something deactivated for the test. I don't know where.
Yeah, I guess so. Or also maybe that test, I don't know if it's running for Zenoh. Because I remember maybe in CMake or something like that, it's actually matching RMW implementations explicitly or something like that. So I'll be honest, I didn't look into it for a long time. So
Okay, we'll figure out and we'll see what we can do for it. Yeah.
Yeah, I think that this is a starting point, right? And then we see the status and what to do next. But at least we get an idea.
They're mostly
and another thing I'll dump in the chat is like the how we kind of like compose rules today in SROS 2, just to give an idea, which is like basically as stuff sometimes changes in the lower level of ROS, like what are the topics exposed by a node. If you go into the command folder, and yeah, click on lifecycle node, for example. So lifecycle node exposes these services and the transition event, but also it includes nodes.xml that defines all the topics that are provided by a node. And so that's the kind of abstraction we use to then, like when we actually generate policies, we say, okay, we have a node that publishes chatter, but as it is a node, it will also expose all this. So that allows us to like not repeat and especially not have to change to 100 places when something changes in ROS 2. We can have like a full list of and so that's what we use on our side to then like compose things. But if we can dump in JSON, like that's not really an issue for you. Maybe it's just like a remark for, yeah, if by chance something changes in RMW or in RCL, which like what are the things exposed by a node, most likely that's a place where we need to update it. But yeah, I think that security is a very good place to start. I'm not sure how readable it is, but that's what is used today. It's not doing cross RMW communication, I think. I think it's really just test communication does cross middleware communication, but this one doesn't. And so that could be a good set of things, even if it's modified to be hard-coded, to be sure that like, at least we can test secure communication in CI before generating things on the fly.
Okay. Yeah. Yeah. So that's Turtlebot 3. Okay, we have some Turtlebot 3, so we can give it a.
Well, actually, you can really run it with just a Docker listener. I mean, it doesn't have to be a very, very complex. I think we just like dumped that because there was not an easy way in Ament index to like ship those with SROS 2. I don't remember why. But yeah, so this is just like the templating. It was just for you to have an idea, but usually you should not have to care about this. It's just like to know how we abstract things. But I think the thing, yeah, you might care about is the stuff in system tests to be able to modify tests and test security. And then I guess with Ruffin, we'll look like once we have the model in XSL, how can we dump that into a JSON using the Zenoh template or the Zenoh example you gave us, and we can try to plug that into that test suite.
Okay.
And I'm saying a lot of things, but like in the next couple of weeks, I'm gonna be super swamped, so I'm not sure I'm gonna have the opportunity to look into it in the very near future. I don't know how it looks like for you, Ruffin.
I'm following the version 1.0 PR. So as soon as I see it merged, I'll try and experimenting with this.
Perfect. Awesome.
Okay, so On my side, yes, in the next couple of weeks, I shall be able to at least to provide some configuration file for Zenoh for talker listener and Fibonacci examples.
Awesome. Yeah, if you can give an example of like Fibonacci, talker listener, and whatever the basic service call is. And this way we have like example of the three main primitives like action, services, and topics.
Yeah. So yeah, for services, add twins. Yeah.
Yeah. That one.
Okay.
Awesome. Well, that's exciting.
Yeah. Okay.
Yeah,
So,
thanks so much. So sorry, go ahead.
I think I will just asking if there are more questions or some other topics to discuss. Otherwise, I think we are good to progress. Yeah.
All good.
Awesome. Well, thanks everyone, and let's chat soon
Sounds
about
good.
it.
Bye-bye.
That's it.
Yep.
Right.
See you soon.
Bye-bye.
Thank you. Goodbye.
Bye, everyone.
Bye bye.